In this video, I'm going to show you how to use a logarithm to solve an exponential equation. So in number 1, we have 4 to the x is equal to 24. And sometimes with exponential equations, you can get a common base and then you can solve it that way. But there's nothing that you can change 24. Like I can't do, I could change 4 to be 2 squared and then I could try to change this, but like 2 to the third is 8 and 2 to the fourth is 16 and 2 to the fifth is 32. So there's no way I could rewrite 24 with a base of 2. So, and I can't rewrite it with the base of 4 either because there is no exponent 4 can be raised to give me 24 that's a whole number. And so I'm going to have a decimal answer. And so the way I solve this using a logarithm is to put it in log form. And so the base of my log is the base of the exponent. So this is the base of the exponent, so that's the base of the log. Then I'm going to put my 24 here, and I set it equal to x. So logarithms always ask the question, what was the exponent? And so all you do once you've changed the form is to put it into the calculator. So I'm going to go to Desmos, or you could use a TI-84. I'm going to hit functions, and then I scroll to find log with the little a. And then I have 4 and I have 24. And for today's video, I'm just going to round to the nearest hundredth, which is 2 decimal places, so 2.29. All right, number 2, same thing. I'm going to write it in log form, so log base of 3 of 30 is equal to x. And so the base is the base of the log, and then this is how we set it up. It's always equal to what the exponent was. So then we go to the calculator. Again, we do functions, scroll to log base 3 of 30, and we get 3.095. The 5 rounds up to 9, so 3.1. Whoopsies. All right, number 3 is actually one that you could use, the change of base rule, and so I want to talk to you about that. If you know your your exponents, your 4 to the first, 4 to the second, 4 to the third, and you can think about it quickly here, you could change this to look like this, 4 to the third, because 4 to the third is 64, and then I know that x is 3. But you can also use logarithms when you're able to change the base. So I'm gonna, if I wanted to check this with the calculator, then I could do the log rule of log base 4 of 64. So I can do log base 4, 64, and it will also give me 3. So this works when you have whole numbers or not. All right, so let's crank it up a notch, maybe a little bit more difficult of a problem. So I'm going to skip over to this 5th example right here. So I would have log base of 4 of 360 is equal to 2x minus 1. And so I still set the log equal to the exponent, and my base of my log is still the base of the exponent. The way I do this in the calculator is I wait and to type anything in until the end. I like to keep my answer as accurate as possible to the very end. So I'm going to add 1 to both sides. So now I have log base 4 of 360, and I'm just going to put my parentheses here to show that goes there. And then I have my plus 1 is going to equal 2x, and so then I would divide by 2. And I'm going to do my plus 1 divided by 2 all at once in the calculator instead of rounding in the middle. And so I would do log base 4 of 360. I'll go ahead and hit the fraction button. Up here at the top, I'm going to put my plus 1, and then I'm going to put my divided by 2, and so that gives me 2.62. All right, so number 6 here, I would do log base 7. So again, the base of the exponent is the base, the little subscript of your log. And then I have 56 is equal to the exponent, x plus 1. So my exponent is always what my log is equal to. And then I'm going to just do that one mathematical step here. It might help you to put parentheses around what's inside of your log. Take away the 1, and then I'm just going to type it in the calculator all at once. So I have log base 7, I think it was 56, but I'm going to go back and check, minus 1. Yep. And I have 1.07. All right, let's do this last example here that's a little bit harder. So if I'm looking at number 9, and I got a lot of junk going on here, you have to get your base to your exponent alone before you can switch forms. So I'm going to take 5 away. That's equal to 9. Then I would divide by 3 because it's not part of the base. 9 over 3 is 3. And now I can do some switching forms here. And so I would have log base 4 of 3 is equal to the exponent because logs always equal exponents. And to get x alone here, I would need to multiply both sides by 2. And so by not rounding until the end, you really keep your answer the most accurate that it can be. So I have 2 log base 4 of 3, 2 function log base 4 of 3, and I'm going to round to 2 decimal places, which gives me 1.58.